Stars. So they're made from fusion of hydrogen into helium in their core. Some of the bigger ones can fuse other things as well, but it's definitely nuclear fusion producing their energy. So where do they come from? Well, they start in a nebula, which is a cloud of dust and debris in the solar system, in a much larger than a solar system, in the universe, usually part of the galaxy. And those nebula will begin to spin and fuse hydrogen into helium, and you get a protostar. So your protostar is the first stage. It's when they're actually not able to fuse on their own, but they're starting to rotate quickly and heat up. So depending on the size of your protostar, you have one of two routes. Larger stars will go to the right. They become large main sequence stars. Those would be your O, B, and A spectra stars with high luminosity. Your smaller stars will go to the left. Your F, G, K, M stars, smaller, less luminous, and they're the average ones like our sun. So they're going to be fusing on the main sequence for most of their lives. At the end of their lives, they're going to get larger. So red giants are your average stars like sun. So they're going to swell up. When our sun swells up, it actually engulfs the Earth. But don't worry, it's not for another 4 billion years or so. And then as it swells, it's going to actually, well, let's stick with the sun. So as it swells, the red giant will shed its outer planetary nebula, and all that will be left behind is a white dwarf. A very, very, very hot, but not very bright star. It's not even really visible to see many white dwarfs. They're really hard to discover because we need large telescopes to collect enough light to see them. But that's where our star's fate lies in a few billion years. Now, larger stars, so we left off on the main sequence, they're going to swell to what's called a super red giant and then explode in a supernova. That explosion either results in a neutron star if they're on the smaller side, and in a black hole if they're on the larger side. So black holes are still a very mysterious thing to us, but we know that nothing can escape them, not even light. That's why they call them black holes. And then your neutron star is a very, very dense star. So just to retrace, let's go back to the top. We start with a nebula, then you have a protostar, main sequence, red giant, planetary nebula if it's like our sun, or an explosion if it's big, and then you're left with either a white dwarf for small stars, neutron stars for your medium-sized stars, and then your large stars become black holes.